Up next, Team Mile 2.
This competition is definitely not the first competition for your team, as you can demonstrate the t-shirt from the last fire hack. So how did you come about to join this challenge? Did you hear about it from the mailings, or how did you get excited to rejoin?
So the way that we heard about it was actually the company owner, Jeff. He just sent a message saying, "Hey, look, it's up again." I was like, "Oh crap, I didn't even know." And as soon as we found out, we just immediately went and signed up, started downloading the software and getting to it.
So I think it would be good to just start by looking at some of the video from one of the competition games that we had. So I'm going to hit play and we can see how it evolves. So your team is blue here on the right, and they're progressing to the left. And some of it, I don't know if this is a surprise to you, their behaviors in this particular game, but my guess, you have an idea of how it's structured, because I think you had deterministic behaviors for this implementation. Now, is there any insight that you might be able to give us as we look at the playback? Because there's probably some things that you may have realized by seeing it, but you can also inform the rest of us. So I'll play it again. And
so watching this back is interesting because it really, I think, matches our expectations with what we learned about this game. And this ties into our original strategy. So our original strategy for this competition was kind of a two-step approach. One is establishing a baseline using simple heuristics. And then once we have that, try and improve upon that by developing a deep reinforcement learning approach. Sadly, we never got to stage two, given the short length of the competition and our relative inexpertise with the simulation software. But the first part really played out well, thanks to Josh's implementation of a state machine based off of classic, video game AI techniques. So we went with that state machine approach for a couple of reasons. The first is a quote from Martin Zinkovich, I believe is his name, over at Google, which is, "If you think that machine learning will give you a 100% boost, then a heuristic will get you halfway there." All right, and so that's why that was step one for us, is trying to establish that baseline and understand the domain that we're working in. So watching the replay, we quickly learned a number of features that are relevant and advantageous to know about for this competition. For example, the buildings, none of them are rotated. We always know that we can deal with an orthogonal surface, so we don't have to worry too much there for building out complex collision avoidance routines. As far as the flag is concerned, it's actually within the mission file itself. It has a certain amount of variance associated with it, which I believe is a normal distribution definition of variance there. And so we could see that it generally spawns toward the back and a little bit more centered. And so that played into the initial strategy that we can see here, which is admittedly all fairly hard-coded.
Yeah, and it's great that, I guess, the approach you took, creating a stable baseline and then just trying to improve, so that given the short timeline, when you ran into barriers and trying to get to the machine learning phase, at least you had something you could work with. And so that's great. And so some of the strategy that you did implement, it looks like you had divided it into different behaviors. And how did you decompose this problem?
Absolutely. The way that we decomposed it was, step one, we already knew that we wanted to create a state machine of some kind. And so we created a simple interface for that, where essentially for any given state that an agent is in, it does two things. One, it checks what state should I be in next? Should I continue to, try and navigate to the enemy zone, or should I start searching for the flag? And then after that determination, what action should I actually take? And so then we just tried to decompose it in a natural flow. Okay, what the problem that we're trying to solve is capture the flag. Let's start with the capture agent and figure out what states do we need in order to accomplish that. And from that, we were able to create, I think it was around 6 to 8 states where it's simple things like navigate to enemy zone, avoid building, search for flag, navigate to flag, return home. And from there, then we have a wonderful decomposed structure where we can easily say, okay, this functionality goes here and there, as well as then saying down the road, when we do get to more advanced techniques, all right, when we are in this particular state, now we can enable those deep learning policies that can take more complex actions than the ones that we had hard coded in.
As you see your team progress through the phase of navigating the buildings, it looks like they mostly turn right. Is that part of the heuristics, is to take right turns when they encounter an obstacle?
Yeah, so the solution for going around buildings, we were thinking about it, and we were thinking of all kinds of different potential implementations we could do with that. But we decided to go for something that was very quick initially, where you see a building in your path, you don't want to collide with it, you turn right, and you keep doing this. And this is a heuristic that worked surprisingly well. So I think while we revisited it a couple of times, we decided not to change it because it was simple and it got the job done. Because we definitely looked at, figuring out, we want to go to this corner of this building and then continue. We also were looking at, how do we circumvent buildings when going in a diagonal towards that building. But at the end of the day, the simplest solution won out because we just skimmed the building. And I don't believe that buildings can be too close together, or at least it's improbable enough that we were always able to just circumvent the building.
If you had to change any of the strategies for the heuristics, now that you've seen some of the performance, are there things that you think you would improve by changing those state behaviors? Or I know you wanted to get AI in there too. Are there particular states that would benefit from AI?
I feel like we were playing around initially with training, using the OpenAI gym to train an agent to cross all of the buildings and get to the other side. And that would have been something that would have been interesting to get in with AI. But when it comes to the actual searching for the flag, given that we don't really have a whole lot of evidence to start with, the jamming agent, which is the first agent that makes it across due to its speed, we had a kind of circular search pattern that it was doing, and I think we see it a little bit in this demo, where it kind of does a bit of a circle to try to maximize the space that it is looking.
Nina, I know you worked on the jammer agent strategy. How did you attack that problem as you tried to specialize roles?
Okay, so initially for the jammer implementation, its effect was pretty small defensively, as it had a large area to defend and only seemed to be affected if it got a little more lucky. So we changed to the jammer, moving to be more offensive, allowing it also search for the flag, leading to the faster flag pickups.
Yeah, most of what I was focused on was the heuristics at baseline, but also thinking about the complexities of the domain and environment. Looking ahead, right now this is a simulated space. It had very rigid constraints. We did utilize some knowledge about probabilistic space of where the flag was going to be, but looking in the future, thinking about some more complex type tactics, thinking like tag teaming, for instance, like the jammer offensively with the scanner, having those kind of patterns collaborating together. Because in reality, most times when you do have these small scale type units, there's going to be specialization, but also general functions that they have to perform all together. So a lot of my work here, in short, was thinking about those kind of high level strategies that connect to real world domain tactics.